Well, recently I've been working at increasingly higher frequencies up into the millimetre wave frequency bands. This is mainly so we can exploit the advantages of smaller wavelengths with more available bandwidth. One project which particularly benefits is a small 60 GHz radar sensor, of which I designed the radar circuitry for. In this band there's 5 GHz of bandwidth, which allows for a high resolution sensor. But also, the short wavelength of this frequency allows the antennas to have a smaller aperture whilst maintaining a directive beam pattern. This project was particularly challenging, as every component needs to be carefully considered to maintain the signal integrity. But the main achievement from this project was that we were able to combine my radar circuit design, which fed a pair of slot array antennas on the same PCB. Millimetre wave electronic design is traditionally considered to be complex and expensive, but I feel I'm making a difference by bringing millimetre wave electronics into a low-cost applications, which previously would have been out of reach for many different markets. I've co-written a paper on this, with some of my work being published by the IEEE, titled Low-Cost Millimetre Wave Radio Frequency Sensors, New Applications Enabled by Developments in Low-Cost Chipsets. Working at Plextek, I'm fortunate enough to work alongside some very experienced and knowledgeable colleagues who have mentored me along the way. Marcus Walden, our antenna expert, has introduced me to many new antenna techniques which have inspired me to think about how they can be used in different applications. Our principal consultant, Steve Greendale, has also helped me through the radar circuit design, helping me understand the critical aspects of the design, but allowing me to solve the problems myself. I've found this is a great way to learn, as well as thinking about how to improve each design further. My focus has now moved over to tackling the antenna aspect of the radar design, as I am currently working on an electronically steered variant of the radar, which requires different antennas to steam the beam as required. Although this is particularly focused for use with radar, it is also important for millimetre wave communication systems, where a directive antenna can provide additional gain.